Good afternoon, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor, Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you. Thank you, Rashmita. I will quickly share my screen. Okay, so good afternoon, everyone. I hope all of you are doing well and you all are safe at home. And I can see a few of you have also joined uh, us in the morning session as well. So let me get started, and I will just quickly walk you through the agenda first. Okay, now just give me 1 second. Let me just sip some water. Okay, so we are discussing about the distributed computing on Azure using MapReduce and Spark. So we will be going through the details of the MapReduce. Uh, what is the what is a mapper? What is a reducer? How the entire flow of the MapReduce job execute. We will talk about the Hadoop 1, and we will understand the problems which were there in Hadoop 1.0, and then why was Hadoop 2.0 introduced, which used yarn, and where the MapReduce where the job tracker was broken into multiple further pieces like that, and one of them became the yarn itself. So we will understand what is Hadoop 1.0, what is 2.0, and then we will also understand how or why Spark is so fast. So you must have heard about that Spark jobs, they run 10 times fast when they use disk, and they run at least 100 times fast when they use RAM. So what is the why, how, or what has enabled the Spark jobs to be so fast? What are the optimizations which Spark is doing as such, and what is RDD, and all the details around it. So we will jump into the depth of the various technologies as such over here. Now I'll just show you the learn module which is there. So I'll click on it. Okay, so whatever we are discussing is also available on this learn module in a very structured manner, like step 1, step 2, step 3, like that. So if I just take you through the objectives which we will be covering, just give me 1 second. Let me open another tab. Okay, so we will be actually covering both MapReduce and Spark. So let's go through that. Okay, so the objectives of this session as well, and if you go through the self-learning module, then also what will you be able to learn from that? So we will understand the distributed programming model of MapReduce. How does it work? The depth in-depth analysis of it. We will understand the how does it exploit the data parallelism. We will understand what is input and output of map and reduce task. How the yarn architecture, how does the job scheduling works? What are the various strategies of task scheduling? What is yarn? How does yarn add benefit, or what was missing which yarn added, and so on and so forth, and which is basically Hadoop 2.0 or MapReduce 2.0, like that. So this is the first set of learning objectives we will be covering. And I will request you to go to that particular MS Learn module to further go and maybe revise the all these objectives later on, or maybe when you need to recall them, or maybe have a look at the details one more time, then you use that. Okay, the second thing which we will be focusing on is the Spark architecture over here. So the programming framework itself, the architecture, the job flow. We will also go through the job flow of MapReduce as well, and we will go through the RDT, and we will go through the, we'll compare that how is RDD making a difference, or RDD actually is the backbone of Spark. So we'll understand about that, and we will go into the depth of Spark, and we'll check it out. So the these modules are available on the link over there, and I will also just put that in the chat window for all of you to bookmark as such. Okay, so let's get started. Okay, so first of all, we have to understand that what is the, so if you want to understand MapReduce, you have to get somewhat first you have to get the high level overview of what is MapReduce, and then you have to look at the cluster level and at the job flow level, how that is executing, like what are details inside it. So I will just start from the very, I'll start from the very basic itself. I'll just go through the like the overview of what is a mapper, what is a reducer, and then we will take multiple passes through that, and then we'll further go in more depth and so on and so forth, and then we will be able to compare all the three architectures which we were planning to cover, right? And then we will see that how is this mapping to Azure, or which Azure service does what, and the details around that. Okay, so the very first, what is this map? What is the reduction operation as such? So I'll start from very high level, right? Okay, so let's say this is your input data. You have the input data, input data over here. Now this input data is somewhere in Hadoop distributed file system, and this box is representing that HDFS location, like that. Now inside this, and if you're aware of HDFS, HDFS will have default block size. So we will be discussing about Hadoop 1 and 2. So I'll just start putting some details as well. In if you work with Hadoop 1, then the default block size will be 64 MB. And when you and in Hadoop 2.0, the default block size is 128 MB. So this is 128 MB, and this is, let's say, one block over there, block 1. And this is block 2, and so on and so forth, like this. And this is some block number n. So my file was so big, my file was broken into these blocks as such, and or it was written in these blocks over there. And then what happened, I had to do some analysis on top of it. Now when I talk about analysis, what comes to mind? So uh, I'll just make a very high level diagram, then I'll show you one particular image analysis which I would like you to understand, and then I will also show you another variation of that with maybe a number sort, like how do you do a, maybe how do you will sort the numbers as such. Okay, so on a very high level, what happens? You see this block which is there. There is actually one more thing over here called as a split. So I will just make this dotted line split. Now split can have more than one block. So this is a split over here. More than one block is possible, right? So keep that in mind. Now what happens? The one split will be getting processed by one mapper job. So I'm just gonna make one arrow first, and let's say this is the arrow, and this is one mapper job. What is inside the job? What runs over there? What are the details of it? And so on and so forth. If you know it, that's great. Otherwise, I'll just give me 5 minutes. I'll sort of explain more about what may go in those boxes over there. Okay, so this is basically the map jobs are run running over here, and somewhere maybe one more box. So one split will be, it will be processed by one map job. So this is some n number of job. Now what happens? Whatever job is executing over here, right? You're doing some sort of operation, some multiplication is going on, some sort of maybe you have the input data and you have your operation and you multiply with that and you basically operate on it. And then what happens? The outputs are there. So the outputs which are there. So let's say these are the outputs which are coming out like this. So output, and there is a big cluster. The cluster is having multiple nodes and multiple things are there and so on and so forth. So now in that same cluster somewhere, some reduction jobs are running. So imagine these two jobs are there. So this is reduce job one and reduce job, another reduce job. So like this over here. Now what happens? You see the arrows which I have just created over here. This is where a lot of things happen, and this is where we have a lot of problems as well. So when the data moves, like when the output of the map job, it basically you can say is read by the reduce job over there. That is where a lot of data movement will happen, and this is where I will also say that if you have map and reduce both the job, then at this point in time, the output, the intermediate output. So this is the intermediate output over here will go into the, let me just write that properly. Okay, so this output basically goes in the local disk, which is there, some local disk on the node right now. Okay, what happens if I don't have any reduction job? I have a reduce less job. Like basically there is no reduce job over there, only map operation is there. Then the output will go in the HDFS like that. So first thing which I would like you to remember is that lot of disk read write will happen in Hadoop. That's that's one of the problem which Spark will solve later on. Okay, so let's put that for we'll tackle that after 30 minutes. Okay, now these are the reduction operations. So a lot of shuffle over here is happening, and a lot of data is moving from you can say one location, one node to another node, and so on and so forth. So here, basically, we can call this as the intermediate output, or we can also call this as partition. So the output of the map job will be partitions as such, or you can also call them intermediate output or partition. So one mapper is throwing some partition out. That's the output of it. Now that partition was moved to the we can say another node, and then more maybe merge operation will happen on top of it, sort operation will happen on top of it. Finally the reducers will pick it up, the final partition which is there, and then the reducers will run the job on top of it, and then we are able to, and they basically are doing aggregation over there or some sort of maybe another top of sort over there or something sort of a reduce operation, and then this is the output, and the output goes to the HDFS. So this is output block one, this is output block two. Two boxes are representing two output blocks right now. So this is going to be output over here, and this is again output over there. Okay, and where does this go? This will go in HDFS like this. So the uh, as such output one and two like this. Okay, so on a very high level, this is what is happening. What Hadoop is trying to do is it is trying to, what MapReduce is trying to do is it is trying to break the big job into smaller tasks, and those tasks will be further executed, and then uh, and and by using multiple server infrastructure or multiple nodes as such, we will try to make sure that things are as parallel as they can be, and all the things and optimization such as move the job to the data, don't move the data to the job. All those things are the founding principles on which Hadoop architecture is, you can say, created. Okay, so this is on a very high level. Let's jump into the, let's go into it. Let's see what else is there, and let's see if we can have few examples of what type of mapper and reducer jobs are possible. Okay, so I'll give you one example first, right? Let's start from somewhere. So in this example, what we are doing, we basically have a lot of numbers with us, and in the input file, a lot of numbers are there, and a lot of input files are also there. And we would like to sort these input these numbers in order, like maybe in descending order or ascending order. You want to uh, sort them. So the how will that job look like? If I just repeat whatever we have just discussed, if one more time, then how is gonna that look like? So this is going to be the okay. So this is one block. What was one block? One block was literally that 64 MB block or 128 MB default block as such. Can I have a different block size? You can have different block sizes. So this is where this is my block one and block two. So block one and block two. Where is the data? Data is obviously inside that. So where is the split? Split can have one or more blocks, right? Now, generally what happens, we do one-to-one mapping, like one split has one block. So it's a, you can say optimization or data localization technique as such, or a pretty common sense type of thing, like don't move the data around as such. So this dotted line is representing split over there. So this is split one and that is split two. Okay, so this is one split and that is representing another split over there. Okay, great. Where is the data? Let's put the data points over there. So we have some numbers over here, 113711 something like that, like this over there. And maybe we have some more numbers over here. That's what is there inside the file as such. So we have something like this. Now, okay, so what are the various phases which will happen? First thing is this particular split will further be, you can say, broken into record. Uh, you can say we call them RR as such, or record readers as such. So what happens over here is if I just try to make few arrows over here, something like this, like that. So the input split is basically going to be further broken or transformed into some key value pair. So this is one key value pair. This is another key value pair. I'll just make few boxes, right? Like that. So these are different key value pairs like this. And what is the key value pair inside it? Let's write some numbers over there. So the first is, let's say, key and the value is 1137. Second key is 21103. Third is 1242. Fourth is 0932, and so on and so forth. And what is this? The last one, this is some n number over there, and 0243. These are RRs over here. Now, what are these record readers? These record readers are basically key value pairs. So key value pair which are created on the input data, like that. This is like a normal step which happens. Okay, now then this basically goes in the mapper. So I have one split is equal to one mapper. So I'm just gonna make two mappers right now. I just want to go. I have just created two splits over there. So this is my first mapper and this is my second mapper over there. Where is it running on which cluster node? Where in the cluster? I'll come to that. So, but let's say this is first mapper over there and another mapper is there like this. And they are they took that the RRs as such and they ran the job on top of that. So the job executed here and maybe over here. And what is the output of mappers? We get partitions as such. Okay, let me just remove that. Yeah, okay. So the output of this will be partitions as such. So what are those partitions? Partitions are the intermediate outputs which are coming. So what will I get out of this mapper is basically uh, partition 1, partition 2, partition 3, partition 4, partition 5, and so on and so forth, like this. All these partitions are coming out like this. So partition 1, 2, 3, and so on and so forth. It further goes down. So this is the output of the map job. Okay, so what can we call this? This is the intermediate output. So like this. So intermediate key value pair. Key value pair. Now, these partitions are the ones which actually will be shuffled across your different nodes where the mappers are available. So let's say this is going there, this is going here, this is going there, and maybe this goes here, and so on and so forth. And this is where the lot of data movement will happen, and this is somewhere uh, we will see if we can have a few strategies to reduce the data movement or to reduce or optimize or whatever can be done. Okay, and then we have these mappers over here, and these mappers are also running somewhere in in the cluster, somewhere it is running over there. So this is the mapper, sorry, this is a reducer. This is the reducer over here. The mapper is on the left hand side, right? This is the reducer over here. Now it's totally possible that in your job only mapper is there, reducer is not there. All those type of things are possible. So then the output of this is basically what we are thinking, that we will get the output file, and in that output file the data will be sorted in the order needed by us. So imagine this is output block 1 and this is output block 2, and the data goes in the HDFS. So this goes to HDFS over there like this. Okay, what might be over here? Uh, I may I may make some mistakes over there in the numbering, but I think you'll get the point. Let's say 3, 2, like this, like that, right? So we have the numbers are now in the uh, in you can say are in some order as such, like this. Okay, so this is another example of how that mapper and the map task and the reduce task will look like. Okay, one more thing. Now let's understand this again from from image point of view. I'll just take 2 minutes of your time, then I'll just move to the you can say we'll go in more depth in the concept. Okay, so I'll just quickly in my secondary screen I'll just quickly uh, open one picture, and I will just see if I can pull that picture over there. Okay, now okay, so this is where we basically have edge detection going on over here in this example. So there is a filter called as this is basically a Sobel filter, which is detecting all the edges. So when we do image analysis, we have various type of filters which can detect the horizontal edges and vertical edges as such. Why do we do that? If you can detect the edges, then the algorithms such as the convolutional neural network will be able to further understand those features from the input images, like any texture or any different type of features which are there. So if I take this example, right, let's say you had millions of images or billions of images, and you wanted to do the operation uh, on top of the using the MapReduce task, then how what could you have thought of? Like what were the various options as such? So first option was that you could have simply uh, that's okay. So this is the HDFS block over here. Okay, so let's see if I can make a straight line. Okay, and then these are the blocks over here. Sorry, that's representing the entire input file, and these are the blocks, the individual blocks over there. So you have millions of files as such. So maybe there is one file here, there is one picture here, there is one another here, 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 and so on and so forth. So one thing which could was possible is you could have simply you could have simply created as many blocks and those many map jobs over there when the split is equal to one split is having one block. So let's fix that. That in the examples we'll think one split is equal to one block. So we don't have to go in any other direction. So how many jobs will be there? So if I have millions of splits over here, then I will have millions of these map jobs which are running, and these map jobs will be so small. And what are they doing? They are simply running the Sobel filter over there on top of it. What is the Sobel filter? You can, I think, if you just look up in any of the any of your maybe go to Wikipedia and have a look at it, right? What is the exact formula for it, which we execute now? So these are the various map operations which are running over here, and there is no reduction going to happen because you did a one-to-one mapping, and one image is equal to one map task right now, and you got the output. So and there were so many map operations, you must have faced so many issues, but that's what how it may look like. Second thing which you can do is you can use, we have features like sequence file as such. So which basically means is that I can have multiple images in one sequence file, so which will look something like this. So instead of uh, So instead of one single image over there, let's say you have multiple images. This is another you can say line of thought which you can go for that. Okay, let's do it like this, and then we will have less number of mappers now, and we have these bigger chunks to process, and we will be able to we don't have to run those small jobs in all the locations, and things will work better for you. Okay, something like this, and then you are getting your and the outputs are coming which are looking like that, and this is where the and this is the image which where the uh, edges are detected, all the edges as such. Now another thing which may happen is but only here also only map job is there. How can I have how can I explain that you may be requiring the reduced job also on top of the map operation? Imagine you had such a big file. The image which you found was such a high resolution that it didn't fit in one block like that. It is spanning across multiple blocks, multiple splits as such. So this is my image. So my image is also pretty big as such. And okay, and what you had to do to be able to process that is this is the picture, right? The full image. Now this is where one map, and this is another map job is running for that much of data. This one is for this, and that is for that. So you have one map job here, one here, and one here, and one here, right? And then all the outputs are going in the reduced job over there, and then you got the final image as such, which we were uh, thinking of, that the edges will be detected on that image over here. So this is where that file image output came. So this is another example to understand what type of operations will be going on over there. Now, so let's go into the Hadoop 1.0. So this is on the higher level, this is what happens, right? Uh, and this is standard. This is what will happen in Hadoop. But how does it happen? What was the problem with the various Hadoop distributions which were there? So let's understand that. Like, what was the problem with Hadoop 1.0, and then how was that removed? So let's understand it in this location. So basically, uh, earlier in Hadoop 1.0, there was two things: job tracker and task trackers as such. So I'll just take few minutes to just complete this. But this is Hadoop 1.0. And this is the original, you can say the original Hadoop according to the white paper which came out, uh, that one. So, okay, so here I have the client. Client is basically, let's say this is you. You are using that client node to submit one job like this. And then we will have the job tracker over here. So this is representing the we'll make one more box inside it. So that was actually representing the master node right now, and this will represent the job tracker. And let's say you have two more nodes in your environment. I think I should just make it slightly bigger, and hopefully that clarity will be appreciated as such. So okay, so let's say these are two different nodes in your cluster. We'll write the details on these nodes as such. So this is the job tracker node. So job tracker node, and we have the job tracker which is running here. So let's put that. So this is one of the major component in the original Hadoop architecture, job tracker. And then we will have the task tracker. So the concept was, let's break the jobs into tasks and then schedule those tasks on multiple nodes. And then we will be able to do the parallelization, and things will work out. So this is the task tracker. Okay, this is another task tracker over here, TT like that. So tracker. So this is basically JT. We may be using these terms later on. Let's say TT. Okay, now What is there inside the client? Let's have a look at that. So inside this client, you will have the MapReduce program, the original program itself, which you have written. You wrote this. So MapReduce, like that. And then it will also have a job client over there. Job client will do a couple of things for us. So this is the job client. Okay. And we also have to bring HDFS in picture. So HDFS will have the name nodes and data nodes, right? So this is representing that HDFS right now. This is HDFS over here. Okay. So if I okay, so I think okay. So let's see like step by step what happens in the original Hadoop 1.0. So I'm just gonna put the task tracker node here. So all of this is very important to understand the evolution of these big data tools and why today Spark is so fast and so on and so forth. Right. Okay. So basically, the job was we can say triggered or submitted as such. So let's put step number one. Then this job client will basically go to the this job tracker over there and will get the job ID. So okay, give me the job ID. So okay, now this client will do one more thing. It will go to the HDFS. It will check out whether this particular job was previously executed or not. That's one thing it will do. And if it is executed, it will sort of not do the operation again. That's one thing it will check for. Okay, let's say that was not the scenario and that didn't happen, and we are doing it for the first time. So now what happens over here? It will copy the resources. So copy job resources in HDFS directory. So what are these job resources? So for example, these job resources can be jar files, the any jar file for your job, and like this jar file for the job. It can be configuration files. So config file. It can be the information about the split. You actually said that, okay, my split will have these many blocks over there and so on and so forth. So all those information is going inside the HDFS. So in this manner, like step number three, that happens. Okay, then everything is ready and then the job will be submitted. So this job is now submitted. Okay, submit job like this. Now, once the job is submitted, this job tracker will initialize it. So some initialization is going on and so on and so forth. Oh, sorry, let's not put the initialization right now. Now, what this job tracker will do is it will basically go and will uh, it will just go and try to retrieve the information from the HDFS. So this one step will happen over there. Now, so we will say just some retrieve some information, retrieve the information about the input splits and so on and so forth, like this. Okay, now and then let's say that process went pretty fine, and then after that the job was initialized, and then finally the job this job tracker it it just launches the job as such. So this is the launch job. It is asking the task tracker to do something for it. So what this tracker will do, this will actually launch the job. So what it will create, or what will happen over here is basically we'll have one uh, one JVM will be there. So let's say one white box maybe like this, and there are more details inside. There is a child JVM as such. So everything is segregated as such. So there is I should just make a child JVM maybe over here. So this is where the uh, child JVM is there, and where is the exact job which we were talked about, map and reduce job. This is where it will run somewhere in this location. This is the exact map or reduce task will execute over there in that step. Now I have missed few of the things. This task tracker will also will try to retrieve the information from there. So all of those things will happen. A lot of operations against the HDFS location will happen in this flow. Now, a couple of things which we will remember is that initially what happened in the original architecture, there was some fixed number of slots. So one task tracker will have two map and two reduce slot. So you can say that these are two map and two reduce slot. So it means like how many operations can it do, and then with heartbeat, this basically will let the job tracker know that I have executed or not, or maybe if I'm okay to get more uh, job task, or let's say map task or reduce task allocated on the task tracker. So this type of heartbeat mechanism was there. So the communication will happen in heartbeat mechanism. Okay. Now the problem with this is the, you can say this is how the original Hadoop 1.0 looked like. The problem with this happened is that uh, everything was localized into so lot of things are being taken care by the job tracker over there. And uh, for many companies, they were not able to reach the level of or the number of nodes to start facing issues. But I think few of the initial companies were there, Yahoo, Facebook, and so on and so forth, whose clusters were so big that they started facing scalability issues because of that. So what they did is very soon after that, they basically uh, introduced the Hadoop 2.0 in few years like this. One of you can give me the exact date as well. And this is Hadoop 2.0. Okay, now in Hadoop 2.0, what is going on? This is where they have, you can say, so the entire concentration of the jobs which were supposed to, or the task which the job tracker was doing, they have now bifurcated that. So they did two things over here. They are saying that okay, we will do the map reduce. This is reduce is fine, and we will have another component called as yarn, and this yarn component will take care of lot of resource allocation and so on and so forth. So this is your MapReduce 2.0. Okay, so what was the difference between it? So the first one didn't work out. It had a lot of issues as such, and there were problems with the name nodes also. Now here the flow will more or less look same. So I will create the same boxes, and I'll take less amount of time this time to make those boxes, but we will be introducing new components of yarn. So this is the client, and the client will have the map program and the job client. Now this client will be communicating with the so this is a master node over here. So let's try to make it slightly bigger this time. Okay, so this is one of the master node over here, and inside this master node the resource manager is running. So yarn basically provides is having two components over there, resource manager and node manager. So here resource manager runs. So resource manager like this, and inside this resource manager we'll have two components over there. Now the two components which we will put here will be the scheduler and the ASM over there. So let's see if I can just use another color to make it more visible. We have scheduler here, and here we will have the applications manager. So applications manager, and this applications manager will be is ASM like this. So scheduler and ASM is there in the resource manager. Okay, what happens at the worker node level? So this is my worker node, and let's make two of them if we can do that. So this is one worker node, and that's another worker node. So in your massive cluster. So okay, and now what we will have, we'll have node managers there. So these node managers are one per worker node, and the resource manager is like a global one single per cluster. Don't worry about the high availability things. We have things in place. If something goes down, few of the tasks will terminate, but uh, it is able to create it. We have checkpoints concept, and then it will be able to carry on from the checkpoint. So this is node manager for this node, and this is another node manager over here, manager like that. Okay, let's make that HDFS cloud as well. So this is HDFS over here. Okay, like this HDFS. And just to visualize, maybe where is this HDFS really in this diagram? I would like to put it somewhere here, so that all these nodes have that distributed file system. So this is where we will put one box and we'll say this is distributed file system, which is HDFS. So like this and like this and across so many different nodes which you have. So this is just representing that overall like that. Okay, now what happens in this Hadoop 2.0 over here? So the concepts of we'll have the inside the client over here. We will have the same to the MapReduce program and the job client. So this is MapReduce program and this is job client like that. Okay, so let's understand the flow with Yarn now. So basically the job was submitted over there. Now it will go to the basically the resource manager and will get the job ID from there. And so let's say job ID and exactly to where it goes to ASM over there. I can make this more to the point as well, but just for your information, it will go to the ASM to get the job ID over there. Now, multiple things will happen. One thing was that the same copy activity will happen. All the jar files and all the anything which is related to your job is now some is there inside HDFS. Okay, then once that is done, the job will be submitted. So the job was submitted like this. Now, once this job has been submitted, there is a thing called a submit app as such, like that will submit the job. Now, once the job has been submitted, the application manager will right away do one thing for the to run this application is it's gonna you can say it's gonna basically I'll put it like this. So the resource manager will basically what it will do, it will start one app master. So step number 5 over here is another thing, start app master like this. So what is this app master? What is this new thing, right? This was you can say uh, let's just see if we can put it here. So app master. Now this node manager is basically gonna do that like this. Okay, just one FYI. How does the resource manager, what does the resource manager tells the node manager? We have a concept of container tokens as such. If we get time, I'll just explain it on the way. Those container tokens are the least tokens, and we'll see it in the flow somewhere. So now what will happen? The let's say step number thing, the container is launched. So this is the launch operation will happen. And now what is this container? Container is literally the logical representation of resources like CPU or RAM. This is one container. So this container was the container got up, and inside the container we will have the application master, and this is the MapReduce application master. So here, like this. So app master for that particular application. Now, same things. It will also go and try to retrieve the information from the HDFS. All those communications will start happening. Like it will go and try to get the more information about the data itself. Now, uh, if the job is very small, it will execute there itself. But let's say the job is not very small, then what happens? Then this node manager, this application master will basically go back and will say, resource manager, I'm looking for resources. Give me some. I'm looking for, let's say, this much amount of RAM and so on and so forth. This application master will go and start talking to scheduler. Scheduler, do you have the resources somewhere? Where can we schedule this and so on and so forth? Now, at this point in time, one more thing was happening is these node managers were also using Heartbeat, were updating about how many, what is the resource utilization, uh, how many uh, how many containers are there, how much RAM is there, what is left and so on and so forth, whatever. All those communication is also going on parallelly. Now, finally, what happened? The application, the resource manager basically will give the token, the container leash token. Now, this container leash token is what this application master will take and will say, node manager, I got this from the global authority. You start my container over there. So this node manager will say, okay, I will do it, and will create the container over here like this, one more container, and so on and so forth. Other containers also in other locations as well. So now we will have a few of the components here. There will be more components like yarn child will be there, and so on and so forth. But this is yarn child one. There is a literally one program yarn child like that, and then this is where the map and or reduce task will run overall in the various nodes which are there. So the now what happens when this how does the communication happens? Like is when this like this MapReduce job is running over there. So the communication will keep on happening. Like this is where you can say that the application master will be getting the information, and this application master can further update the job client about that how much task has been executed and so on and so forth. And then when the final output will come, the final output will go into the HDFS. So here, what are the added benefits which were there in Hadoop 2.0? I'll just summarize that. Now, the instead of okay, first thing is which we will remember is that the job tracker, which was one of the central component of Hadoop 1.0, has been now broken into you can say resource manager. And what is this resource manager doing? Job scheduling, any allocation of resources, and so on and so forth. All those things are doing. Secondly, applications master. So applications master over here. What is this applications master doing? It is doing the task monitoring. How many tasks are running? What is negotiating with other with scheduler to uh, looking for some resources and so on and so forth. So it further decentralized or further got broken into more components as such. Now, what is this scheduler doing over here? This scheduler is doing, it is, you can say, accepting the job. Uh, it is basically negotiating with, you can say, uh, this scheduler is basically, you can say, allocating the resources, monitoring the states, and finding where the resources are there. Application master is the one which is doing the, you can say, negotiating with the scheduler for getting the containers for the applications to be running, and so on and so forth. So if I just take you back to the old diagram, so if you see this task tracker which we have like this option like this, and this is the job tracker over here. So now things have been further broken down. So that job tracker now has been, you can say, is somewhere over here. This app master is responsible for the tracking of the jobs. That's it. So I'll just say job tracker, live tracking of the jobs and all those things will happen. And the resource and the negotiation about the resources, allocation of the resources, everything which that JT was doing earlier. Now we have the yarn, which is having the RM and the uh, NMs over there to be able to do that. Now this reduced a lot of issues, a lot of things started working out. What is this node manager doing? Everything, like sort of kill the container when the resource manager will say that this container, that job done, kill the container. It will kill the container like that. And if you give the leash token to it, it will leash the resources as a container for the uh, job to be executed over there. Okay, now this is also amazing, right? Things are working out, but still lots and lots of read writes are happening with the HDFS location. That problem is also not solved over here, and it is also still existing, right? Now this is where Spark comes into picture. So this is Hadoop 1, this is 2, and then it is you can say, and then I'll just go parallel, and then a replacement of MapReduce is the Spark engine. So what is Spark doing now on top of whatever we have done? So this is where Spark also uses yarn. So whatever most of the things which we have learned will remain same. So if I just quickly try to make the diagram of it, it's gonna look something like this. So we will have the master, and this is the master, and these are the other worker nodes which are there. So like this. And now we are talking about the Spark cluster, like this over here, like this. Okay, so what are the various things which makes it faster, right? Let's focus on those things. But I'll just try to complete this diagram in the meantime. So this is the client. The client is the one which is submitting the application. Right? We have the resource manager over here. So you have resource manager and scheduler is running inside there. So scheduler is there. Now the node managers are also there. So that let's make it in the different color. So this is the node manager here. One for this node, one for this node. So node manager like this. This makes the yarn architecture this much over here. Now the okay, so let's see one typical flow in this example. So the Spark application was submitted. Now you wrote the job in PySpark or something, which is possible to be run executed on Spark, like PySpark can be executed over there. So or you can say you ran something. Let's say submitted the application which you wrote over there. Then same concept will happen. This resource manager will basically go and will say node manager create the container and launch the application master over there. So now we have the application master also. So let's make one more box here. So this is the container, and inside this container we will have the app master. So this is the application master. So app master, and inside this app master we'll have the driver program. So driver program is the one where Spark session will be there. It's a session by which we'll get the IDs and all that. So this is the driver over here, and then this is where we have the Spark session. So okay, great. Now once this has been done, the this application app master will basically go and try to get resources. Will say, okay, I'm looking for these many resources. Can you give it to me and all that, so that it will get the leash tokens based on the request. Now and then it will basically go to the node managers and will say that I got the leash tokens. You give me the containers now, right? And I will be running some task inside that. So these are the containers which are coming over here. Now, one little bit of language change. Let me just put the language change first. So now we'll have executors inside these containers. So you see this. We have these executors here. So this is one executor, and let's say one executor is here, like this. So what are these executors doing? These executors are the one where task will run. Okay, but this is no longer a MapReduce task, right? But task is there. So I'll show you what do you mean by task. So this is the executor. And inside the executor, that's your task are running here. And let's say a couple of tasks are running here and so on and so forth. And then the same flow happens. The application master is responsible for making sure everything is the coordination as such, resource allocation as such, and all those things. These are responsible for the driver program and application app master. And then once things will be done, and this is the driver program is communicating like this. Let's say like that using the Spark session over there. And once everything is done, you are getting your outputs. Okay, but what is this task? Let's try to understand this task over here. Now, before I take you into literally the task itself, the uh, the main speed or the reason why we have the jobs which are so fast are because literally like there is no you can say it's the way it is, but the Hadoop clusters, they were doing so many disk IOPS that was slowing it down. Now the Spark cluster will be having big amount of RAM over there, so it will make it expensive, but a lot of RAM is going to be available as such. And the intermediate outputs which are coming will go inside that RAM. And if not possible, let's say RAM is not there, then disk operation will happen. But if RAM is there, then it will go inside the RAM. And we have the caching concepts as well. So literally because of that intermediate outputs being stored in the RAM, or a lot of things getting cached as such, it really will be having a big boost in performance. Okay, but that's not the main thing. That is definitely one of the good solution of, that's one of the good thing which is there, but not the only thing as such. So there is a concept called as RDD. Now this RDD basically is the resilient distributed data set. Now, how are we going to understand that? So let's say you wrote one job, right? This is the job which you wrote, and when this job was created, uh, there is a component called as DAG scheduler. So there is a DAG scheduler component. What this DAG scheduler component will do, it will basically try to create a plan first, like it will create a DAG diagram. DAG is just you can say a type of non-cyclic diagram where the cycle doesn't comes back. Now, the how will it look like? What this DAG scheduler will do, it will create stages as such. So imagine that whatever job you have written, that PySpark or some job over there, which is doing something, it will be executed in, let's say, two stages: stage one, stage two, like this. And then inside that stage, we will be having the task as such. So let's say some individual task is there. So this is part of stage one, and this is part of stage two. Let's say two tasks are there. And then it will also have an idea of when the data will be moving from one stage into another. Now, the way it will create your stages is the tasks which are there inside the stage can be executed parallelly. So this is where parallel execution of task will happen. And then the data movement will happen where I have this arrow. This is where the exchange will happen, or this is where the shuffle operation will happen, or this is where the data will be moving from, you can say may move from nodes to nodes and so on and so forth. And they have done something which is pretty interesting as such. So if this is my input file, so imagine this is my input file, right? Now this input file is now having partitions over there. So this input file which I have, and I will just say that this is my input file and this is my the resilient distributed data set. And this RDD, which is representing my input file right now, is having partitions there, P1, P2, and so on and so forth. So just like you had splits earlier, we'll just put, let's say, P1, P2, P3 partitions over there. Now, the one partition is being executed by one task over there. So this, if I just think of how many, that this is one stage, then if I have three partition, then three tasks will be there. There is a one-to-one mapping over there. So this is task 1, 2, 3. So task 1, task 2, task 3, like this. Now this is the exact task which we are trying to represent over there. But how is this DAG scheduler creates the task? That's also pretty interesting, right? And I'll just take maybe 5 more minutes of your time, and I'll just wind it up. Uh, Now, the what it does is basically we have two type of dependencies, or two type of things will happen. One thing is called as a narrow dependency. Now, narrow dependency basically means that I did some operation, and because of that operation, this is my parent RDD. So this is RDD but parent. Okay. And then because of this, one child RDD got created. I did something. So this is a child RDD over here. Now, when there is a one-to-one mapping, like between the child RDD partition and the parent RDD partition, when there is a one-to-one mapping like this is called as a narrow transformation or narrow dependency. This concept, narrow. Now, what happens when we don't have a one-to-one mapping? Where to create the child, maybe you have to wait as well, or data needs to be moved as well. That is called as a wide dependency. So how will a wide dependency look like? So if this is my parent RDD and this is the child RDD which got created. So parent RDD had multiple partitions over there, and then child is having less number of partition, or you will say that the child is having dependency on more than one partition to be created as such. These type of operations are called as wide dependencies over here. And this is where a lot of data movement will happen in the cluster as well. Shuffle will happen, or repartition. If you do repartition, then this will happen, or group by join something. So The narrow dependencies, so what this DAG scheduler will do is that it will put all the narrow dependencies inside one stage. So over here, this is narrow. And now these narrow dependencies can be executed on that in parallel on the Spark RAM enabled, or you can say in memory computing will happen on top of it. This is also narrow dependency over here. So narrow dependency. Those wide dependencies will go in these exchange operations over here. Somewhere here, wide dependencies will go like this, where the stages will be broken as such. Now, but this is also not the main thing. So this is just what will happen, right? The main thing is that this is just a plan. Nothing got executed, right? Nothing got executed. So the one of the main thing which happens in Spark is the backbone of Spark is RDD and the lazy evaluations on RDD. So what happens in a lazy evaluation? So everything is making sense till now, but okay. But what is this lazy evaluation? So let's make that box one more time. So this is one RDD and it had those partitions over there, right? And this yellow box is representing your file. Now on this RDD, there are two type of operations which are possible in Core Spark as such. Two type of operations are there. You can do actions on top of it. On top of it, you can do transformations on top of it. Transformations on top of it. So transformation will be like filter operation, mapping operations. Those are transformations. Filter is a transformation. And then we have the reduce operation is one type of action. We also have a count operation. If you do count, that is also a that's basically an action over there. Now what happens is because of these, on RDD we will do two type of things like transformations or actions, and then transformations will have a list of it what can be done, and you can say let's put map also, right? Map is also another transformation over there. Now the main thing is that when you do the map operation, right, or when you do the transformation, nothing actually execute. So there is no execution. No execution happens. So what it will do, it will just create, let's say RDD1. From RDD1, when you did that transformation, it will create RDD2. So this is my RDD2. I should say just something like this, RDD2 over there. But data copy will not happen, data movement will not happen, nothing will happen. This is just like symbolic or empty. This is going to be totally empty right now, like this. Now, but when you will do the operations where you have to respond back to the driver, like you need the count or the reduce, this is when the executions will happen. This is literally when the this is immediately executed like that. And okay, so executed like this. Okay, so what happened during the transformation phase? Lazy evaluation is one of the very important thing over here. It did evaluation, but in a lazy manner. So what that enabled? That lazy evaluation mechanism enabled that I can create the DAG. I can do optimizations. I can the Spark will be able to do optimizations under looking at the entire program which you have, and it doesn't have to start executing. Like in MapReduce, it just starts executing. It starts getting the data and so on and so forth. As such, in whenever you run something over there. So here, what will happen is this is basically where it will just say, okay, I have done created this RDD from your RDD, but I am not going to do anything. I'm just gonna see what your entire program does. And once your entire program is understood by Spark, it's gonna do optimization, and there is a big catalyst optimization mechanism on top of it, which is available in the links. You can further go and have a look at it. So which will be executed, and it will try to see what can be cached, what can be executed, what how can we have uh, how can we make things as fast as possible by having some logical plans and some physical query plans. So if I summarize what all makes Spark so fast or so good, will be the definitely in memory computation that makes it very fast. Secondly, this lazy evaluation also gives us the functionality of doing the optimizations on top of on the entire job which we are running. Uh, that also adds value. Caching also adds value as such. So now in clouds, what happens? Okay, or today, what is going on in the world today? Uh, so Spark is pretty on. If you make it on premises, it's pretty expensive, right? If you make a Hadoop cluster also on premise, that's gonna be expensive as well, right? Because that's also a big cluster. Now, but in the cloud, what happens is if you go for any of the Azure solutions like Databricks or uh, Synapse Serverless Spark, so here we are able to deprovision the Spark cluster as soon as the job execute. So you do not have to pay for the cluster after the job execution has done completed, right? So in cloud, earlier what used to happen is Spark was used for real-time processing and Hadoop was used for batch processing. But now in cloud, Spark is used for both batch processing because it will execute faster, and then your job will the cluster will deprovision, and your data will be in ADLS, a data lake or some sort of delta lake or something like that. So, but this is batch and real time as well. Real time. Now we have two major solutions in Microsoft where we can do this. Actually, three solutions over there where we can create a Spark cluster in Azure. So first thing is called as HDInsight. Now HDInsight is uh, the in HDInsight there are multiple type of clusters are possible. I can create Hadoop and Spark both in HDInsight practically. Like this will, if you want to make Hadoop cluster, that's the only location where you can create that. If you don't want to make it with a VM as such. So Hadoop and Spark both are possible in HDInsight. What HDInsight does is when you create your cluster, it gives you more control. More control also means that you have to do more management of it. Second solution which we have in Azure is called as Databricks, which is from Databricks company itself over there. Fully managed server, pretty nice looking control plane is there and data plane, and the cluster will spin up based on your jobs, and you can create lakehouse architecture over here, and you can do stream job, batch job on the same file as such in Databricks using the lakehouse architecture. We also have Synapse. So Synapse Spark is also there. Now Synapse Spark is serverless. Okay, so what happens over here is I don't have to create the cluster. The cluster will automatically spin up and deprovision when I run the job. So if this is my PySpark job and I run it, and I just did the configuration before it, like okay, when someone will come and run the job, create one Spark pool, and it will have three nodes over there to get started with. So when the job will execute, it's gonna spin up those three node cluster or whatever you want as such, and will start executing as such. So the this is the ecosystem of you can say Hadoop and Spark in Azure, and this is and based on the and right now, if you have to really, if you think it through, let's say Synapse Spark versus Databricks, it's an ongoing process. It's an ongoing. Uh, they are releasing services in both Synapse and Databricks. It will be very difficult to answer which is the right choice. It depends on literally what you are looking for. Like if you're looking for the data warehousing functionalities, or if you're looking for the data factory type of ETL functionalities, then Synapse. If not, then Databricks. So it depends on many things as such. But HDInsight, I have a few of my customers who would like to have full control on the environment. They want to log in the head node, install things themselves. If that type of requirement is there, then you go for HDInsight. Or otherwise, these managed services like Databricks Spark and Azure Synapse are managed services. These are we don't have to configure much of it. We have like nice looking UIs, and we click and rest of the things work pretty smoothly over there. So now I will request you to also, I will just take you back to that uh, sheet I was showing. So whatever we have discussed, everything is there in this and in this over here in these links. These links are in the Learn module on the on the meeting page, and it's also in the chat window. Now you would like to, you can go and have a look at it. They even have videos as such available. There is no subscription required to do this. You can just log in and start reading it, and you can answer the questions also on the way, and then you can get the batches, and those batches are socially also shareable. So the Spark, sorry, the MapReduce, and then logically the Spark evolution, and what is Spark doing today as such, and so on and so forth. So I'll just go through the questions, and I think I sorry for extending the session, but I'll just go through the questions. If you have any specific things for me, then just let me know. Okay, so in thank you, Chris. Uh, in Synapse, how do we select serverless or dedicated? Okay, the uh, when you say dedicated, you have dedicated SQL pool in mind. Okay, so let me find that Synapse. Okay, so now this is where we have to differentiate between them, right? So I'll just take maybe 2 minutes more over here, but just to differentiate, this is if this is Synapse, right? If this box represents Synapse, then we have four components there. You have the capability of making a Spark cluster. That's the first capability, like this. I can make a Spark cluster, which is comparable with Databricks. So we call this Spark pool, serverless Spark pool, like that. Second feature which we have is you can create a warehouse over there. So this is the one which will have this is the one which is called as dedicated SQL pool. Dedicated SQL pool. So you will be able to store data in star schema and snowflake schema over there. It's a proper warehouse OLAP solution, like that. Third thing which we have is a serverless SQL pool. So SQL pool, but serverless. Okay. The differentiation over here is that the dedicated SQL pool literally store data. It is literally having a storage layer. It stores data. This doesn't store data. What it does, it creates external tables. What external table means is that let's say this is your or what it does is like what it does is like external table, like similar to external table. So for example, if this is ADLS, where I have the raw file in ADLS right now, and you would like to run queries on that raw file, SQL queries on the raw file, without the need or without creating any cluster or without paying for the cluster and so on and so forth. You just want to run the job and you are just happy when the job executes. That what that help us in doing is exploring our data. We basically do exploratory data analytics with it. You can visualize your data, explore it, make a strategy, see how much data is, what cleaning needs to be done, what type of transformations needs to be done on the data. And once you have the strategy in mind, you can use the Spark to do it on a massive level for you. So you can just pull it over there, and we just covered the Spark architecture where, or maybe use something else, but something like this. And then the last thing is that the fourth component is the ETL component, ELT and the ETL component, which is pipeline. So this will not store data. Okay, that was the answer. Okay, then I think if you have any more questions, let me know, or I'll give you my LinkedIn ID in the chat window. I think we you can connect with me as well over there, and we can continue with the discussion. So we don't have to keep uh, the session already got extended for 20 minutes, so I'll just see if we can wind up. I have the HD diagrams of what I have created over here. If you go to the LinkedIn profile, I am going to just paste upload all the HD diagrams in one OneDrive, and I'll put it over there. So if you need these diagrams, you will get it over there, right? Thanks everyone. And sorry, Rashmita, we had to extend.
That's okay, Shivam, absolutely. If we don't have any more questions, then we would like to wrap up for today. Thank you so much, Shivam, and thank you all for joining us today. Please do share your feedback about today's session, and also please feel free to use the Learn module link, which Shivam has already shared, and it's already there in the chat section too. This will give you access to additional resources to take your learning further. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming sessions. Thank you all once again, and enjoy the rest of your day.